Okay, my phone's messing up. I have to use my older iPhone. I hope there's no issue. So this is the code that I have for the line tracker robot. It's technically for Objective 2, but it could be applied to Objective 1 if you remove a few things. So here I have general stuff for the LCD screen. Applying the right and the left motor. Here I have a couple integers. Here is pretty important for Objective 2 is the line count. Here we're enabling some pins. This is the AACC Mechatronics that I have set up for the LCD screen. Here we have some values for the middle, left, and right line tracker, all being applied to the analog read for pins A5, A0, and A11. And here I put it up on the serial monitor as I was tracking it. So here we have a if statement where if the middle value, left value, and right value is greater than 750, then the line count is going to be added from 0 to 1, and then from 0 to 2, and 0 to 3. This is basically if all three of the line trackers are above the black tape, then the line count is going to be equal to 1, and then 2, and then 3. I put a 500 millisecond delay just so that it doesn't add up like really fast. And for the rest of this, this is just a stack of if statements where if the left value is greater than 750, then I have these values set to where the motor turns left, or the robot turns left. The same thing here, if the R value is greater than 750, then the motor turns right. These two 100s are going to make the robot turn right. These values, I had to constantly change it, but that's basically what these guys are doing. Here's the if statement where if the right value and the left value are both greater than 750, then the motor goes forward. So these 85 and 100 means it's going forward. Then I have this if statement here where if nothing else applies, then it will go forward. This statement probably, like these two guys right here, probably could have been written a little better. One of these might even be redundant. I'm not entirely sure. And then this last if statement here is where if the line count is equal to 3, then the motor stops. So basically, if all three sensors go over black tape 3 times, then the robot will turn off. I'm about 85% sure this code is correct. I have been playing around with it a little bit on my spare time. There's probably a few things that I could change around here, but all in all, it was working for me a little bit. But this is what I was able to come up with. When starting this robot, my initial thought was that this project was going to be a lot easier than the previous one, but I was dead wrong. There was a lot of things that had challenged me, and a lot of things that I had failed to do, mostly the entire project. But regardless, I'm going to go ahead and show you what I got. I was able to display some logic when it comes to the specific objectives for Objective 2, and then I'll show you some failed footage, and I'll go over what I did wrong. The first big mistake that I had with this robot was that I failed to downsize it. I was not confident in my mechanical abilities to make this guy any smaller. I know it's probably, you can't really make it much skinnier, but definitely the length of the robot from top to bottom, it definitely could have been a lot shorter. Another thing that I definitely should have done, which is probably the biggest issue that I had, was to switch from 4 wheels to 3 by removing the back axle and basically just replacing that with a free spinning wheel. By doing that, the robot's turns would have been much more accurate, and especially with 2 axles, when you're making those very intricate turns, it's a lot easier just to handle 2 wheels up front, and then just have a free spinning wheel in the back. Another issue that I had was the spacing of the line trackers on the front of the robot. My initial thought was that they were supposed to be about a medium length, maybe 1 notch apart from each other. But from certain turns, as you'll probably be seeing in the footage in the background, there were certain turns where I thought that the line trackers need to be spaced further apart. And when I did that, based on the code that I had at the time, certain turns would work and then some would not. So I ended up in this situation where I was stuck. I could either turn sharp or I can turn wide. I wasn't able to make every single turn possible. And I thought I would be able to manipulate the code by just adding certain delays, saying okay, well, if the robot has to turn left and it needs to be sharper, then I'll just add a delay to that, and it would just make so many more mistakes, because then it would also apply to the right, for all the sharp right turns. So definitely the spacing of the trackers. After a while, I did figure out that instead of them being further and further apart, they need to be closer and closer together. It wasn't until I got them touching each other is when I was able to get the most accurate steering when it comes to the turns. As far as the code itself, I know I had a few issues. I think what I was missing was possibly a while loop added to the code. I think that using a while loop probably would have made the robot's actions a little more accurate. Because judging by the way I have my code now, it's basically just a whole bunch of if statements just all stacked on top of each other. And while it does work, a little bit in my kitchen, it's not. It definitely did not work out when it comes to the course itself. Judging by the time that I had, and the final code that I was able to come up with, I was a little bit too late. So unfortunately, I'm not going to be able to know whether the code that I have now is going to work, specifically when it comes to the course itself. The last problem that I had was that I rarely ever implemented the middle line sensor in the code. I think the only time I actually used it was in conjunction with the other two when it crosses the black line for the line tracker. I'm sorry, the line counter. I'm sure if I had used some sort of a while loop, I would have been able to implement the middle line tracker a little bit better. For example, I could have made the code so that if the middle line tracker is reading 750 or so, go forward, and if it's not, then it would instead check the left and check the right, and whichever one is higher, then obviously it needs to make a left turn or a right turn or something like that. Possibly a code written that way instead of my code, it probably would be a lot more accurate. All in all, I did learn quite a bit, even though I failed to meet the criteria on many points. Specifically when it comes to the coding, I know I do have to organize my code a little bit better, just so that it doesn't look so repetitive. I'm fairly certain that by switching from 4 wheels to 3, and then just having the axle on the front and the free wheel spinning on the back, that would definitely make the turns a lot smoother. I wish I had more time to put that into action, but unfortunately I was a little bit too late when it comes to that. Of course, there was a lot of trial and error when it comes to the speed of the motors. You had to run much slower than the first robot. So it was a little bit trickier because the 2 motors were a little bit different when it comes to their specific speeds, as well as the speed when the robot is turning left and turning right. I was trying different methods of if it's turning right, I just have the right motor turn off, and I felt like that wasn't turning sharp enough, so I had to find which value is the best for it to turn backwards, so that it could turn right properly at the certain angle. Also, specifically when it comes to the line trackers, I did find that it's a lot better to have them a lot closer together, as close as you can get them, just because it's best to react as soon as possible when you're coming to the turns, just so that the robot can follow the line as accurately as possible.